Jarring Science Club. Today we're going to be learning how scuba suits work and how scuba divers can change where they are in the water using science. For this experiment, you're going to need a jar, some straws, some aluminum foil. The one special supply you'll need for this lesson is a squeezy plastic water bottle. I believe this one is a Core branded water bottle, which works really well for this experiment. We're using the extra tall one because it's easier to see how the scientific principle works. You'll also need a paper clip, a teeny tiny bit of Play-Doh or clay, and some scissors. All right, let's get started. The first thing to do is draw the outline of your diver. Make your diver about 1.5 inches high, but make them about twice as wide and long as your paper. So we're gonna put the head, we're gonna do a head and a little body and some little fishy. Cut out your diver. When you cut aluminum foil, it's best to cut out like the rough shape and then do the detail work because it's very easy to tear. Okay, here is our diver. Next, you're gonna cut your straw to be about twice as long as your paper clip. Now bend your straw in half and attach one end of the paper clip to this side and one end to this side. This is what you want it to look like. Now attach your diver to the straw very carefully because you don't want to rip the paper. It should look about like this when it's done. Now we're gonna put a teeny tiny little dab of Play-Doh on the diver's feet. If you're having trouble attaching your Play-Doh, you can make a very thin piece and then wrap it around the diver's feet. Now it's time to test our diver in a jar to make sure everything's good before we put it in the bottle. If all is correct, your diver will float feet down. If your diver doesn't float feet down, you might need to add more dough to the bottom to add more weight to encourage it to float feet down. Now our diver is floating away properly in the jar, so we can move it to the bottle and see it working there. Here is our large plastic water bottle filled with water. You'll want to make sure that it's filled almost as much as possible with water. And it's floating away at the top. Put on the lid. All right, let's give our bottle a squeeze. Experiment with how much weight you put on the bottom of your diver. If it's too light, it won't sink no matter how hard you squeeze the bottle. Attempt, I didn't have enough weight added to the base of my diver, so it wasn't able to sink because it was still lighter than the pressure from the air. When I added the additional Play-Doh clay at the bottom, the air pressure was able to push it down and the experiment worked. So make sure, if your experiment isn't working the way you think it should, that you test different things to get it to work. That's what science is all about. Here's the science. Here's the science. In today's lesson, we explored a Cartesian diver, which shows how scuba suits work and how divers can rise and sink in the water. A Cartesian diver is named after René Descartes, who is a French philosopher credited with inventing the toy. The reason this experiment is named Cartesian diver is because followers of Descartes are called Cartesians. Cartesian is actually the same name as Descartes in Latin. So that's a fun etymology fact for you this week, a bonus one. This science demonstration actually illustrates the Archimedes principle, which was invented by Greek scientist Archimedes. Thousands of years ago, the idea of buoyancy was not yet discovered. The story goes that Archimedes was having a bath one day and noticed that when his body went in the water, the bathtub overflowed. This supposedly was the incident that started the Archimedes principle, which states an object immersed in water will experience an upward buoyant force equal to the weight of water that it displaces. An object has to be able to displace its weight in water to be able to float. That's why sometimes when you put a bottle filled with air inside of water and hold it down, and then release it, it shoots up and sprays water everywhere. A simple explanation for density is how heavy something is in relation to its size. So less dense things can take up more space, but way less. More dense things can be smaller, but way more. When you first start your experiment, your Cartesian diver just floats in the water. It doesn't move, sink, rise, or anything. When you put your diver in an open container, like we did with our jar, it just floats. Nothing else happens. It's not very exciting. But the interesting thing happens when you put your Cartesian diver in a closed, pressurized system, like your water bottle. A bottle of water is part water and part air. They both take up space, but the water is more dense than the air. When you put your Cartesian diver in the closed system, when you squeeze the sides of the bottle, the air has nowhere to go. The extra pressure forces the air to go somewhere, which goes towards the water. The water then fills up the Cartesian diver and puts pressure on it so it sinks when you squeeze the bottle. But when you release the bottle, the air pressure is released and the diver can rise. Don't forget to go to the lesson portal to get the lesson packet for this experiment, and then come back and take the quiz once you're done. That's it for today. See you next time.